Hi, this is Steve Michelotti from the Azure Government Engineering team. Today I'm joined by Saca, my colleague, also on the Azure Government Engineering team. Thanks for joining, Saca.
Thank you for having me, Steve.
Today we're going to talk about containers with Kubernetes on Azure Government. So I guess the best thing to do for us to start is to just give us background on what are containers, why do we care?
Of course. So I'll start with my first slide. And containers are really just a construct that was created out of using several features that were already available in Linux, provided by the OS, to provide some isolation, mostly namespaces and C groups. Those are two terms you'll hear around a lot when you talk about containers. Containers is just the packaging of those features along with a few others and calling them, giving them a little bit of a branding, containers. But all in all, what is this? And at a very high level, very roughly, it's basically a lightweight VM. Why a lightweight VM? Because, as I said, it's a sandbox where the isolation is provided by the OS. So it's a shared kernel, unlike a VM where there's a hypervisor that provides an isolated kernel, but it still provides you the isolation. And why would you want this? Just like with a VM, you want a more secure environment where if the application has a hole on it and actually ends up going to a place in the file system that it shouldn't, then the container protects you from that. It's also super fast relative to a VM because you don't need to instantiate the whole kernel. It's reliable because you can isolate the dependencies. So you no longer have to worry about, do I have Python 2, Python 3, they conflict, all those pains go away because a container has only the dependencies that it needs. And lastly, it's super convenient. Even as a developer, if you want an SDK that you don't want to install on your machine, you can download the container that has that SDK, run in that sandbox, do everything you need, and then exit out without having to touch your host VM.
Okay, so a lightweight VM, I presume a container is not something that's going to be 2 gigs in size like a typical VM image might be.
Correct. Traditionally, it starts with a base image. You would say, Ubuntu, and that would be pretty lightweight. You can then add instructions in a Docker file, which is basically your configuration file, where you say, bring in all these libraries, run all this code. So yes, you could make it big if you wanted to, but by default, it'll be really small.
And just the other thing I heard you say that's super important is you talked about kind of the environment. Do you have certain SDKs installed, certain tools, certain dependencies? You can encapsulate all those concerns in these Docker images, it sounds like.
Yeah, correct. And even something that's been done to take it to the next level is you can even have an entire build environment set up in a container. So you imagine in the open source world where to build a project, you need to go install all these things and set up all these environment variables. Alternatively, nowadays, you can just download the container, access it, and build the software you're trying to build. So it makes things pretty easy for developers.
Great. So that definitely some very positive things about containers themselves. But what about trying to coordinate all these things? What options do I have here?
Yes, so immediately as you start using containers, one of the key things that comes up is I want to stand up several for HA reasons. I want to be able to ensure that I have a certain quantity of them, so I want to scale out across 20 containers. But if one, has a fatal error and dies, you want to bring it up. You want to be able to say 20, now 25, now back to 20. You also want to have containers communicate across each other, and that's where the concept of an orchestrator comes along.
Orchestrator, okay.
So that's what orchestrators are all about, and that's where Kubernetes fits in. It's basically taking containers to the next level. The things that I talked about lets you do is very declaratively, you can actually say, I want to have X many containers running at once and make sure that they keep running. Even if they fail, just reboot them, keep them alive. It also gives you load balancing, because if I was to do this on my machine, I would need to stand up a load balancer in front of my 20 containers so that we could redirect traffic across them. Kubernetes and orchestrators provide this out of the box for you with a simple configuration file. You can get that up and running.
Okay, so there's different orchestrators that are out there. I may have heard of things like Docker Swarm, but Kubernetes is another orchestrator, kind of best-of-breed technology.
Yes, and in the last few years, a lot of the other orchestrators have announced that they will now support Kubernetes as their core engine and provide a lot of extra functionality on top of it. But the way things are laying out is Kubernetes is becoming the prevalent orchestrator, with other orchestrators now becoming an add-on on top of it.
Okay, so is it accurate for me to say that Kubernetes won?
Some say that.
Debatable?
Okay. I don't know if the other orchestrators would like that term as much, but yes.
Certainly from a Microsoft direction, that's the one we're emphasizing?
Yes, and you'll see that shortly when I talk about what the different options are in Azure. You'll see that we're leaning more towards a first-class support for Kubernetes.
Okay, sounds like a good segue to me. So we've talked about these high-level concepts. Let's drill in a little bit more specifically to Azure and Azure Government itself.
Sure thing.
Tell us a little bit about those options.
So in Azure, there's three main options. You might have heard about a few of them. The first one that we released was the Azure Container Service, ACS, which effectively offered an unmanaged cluster. It was really a way to help you set up a Kubernetes cluster or several other orchestrators in Azure without having to worry about standing up the VM, installing Kubernetes, having them all talk to each other. It did this all for you via simple configuration in the UI where you'd say, I want Kubernetes, I want this version, I want this many nodes, go.
Yeah.
It would create them all for you. And the extra add-on that ACS had is it had the ability to scale for you, where you could say, now I want 25 nodes and bring it back to 5 nodes, which is different from containers. Containers run on nodes. That is more the VM that runs the containers. So ACS gives you the ability to scale out the nodes that run the containers.
Interesting. Okay.
The other key thing, as I briefly alluded to, is ACS supports multiple orchestrators. So you can, and I'll show you this in a second, you can see in a drop-down where we allow you to create Docker Swarm or Mesosphere DCOS. And it's obviously available in the Azure portal as well as through the standard CLI.
Okay.
Then after the changes that have happened in the container space and the orchestrator space, we announced Azure Container Service with a K, AKS, where there's a big focus on manage. So this is where we actually manage the cluster for you. You'll see this shortly as well, where we do not expose the masters in the cluster to you. We only expose the agents, and even those are managed for you, or we automatically patch them and keep them up to date.
Okay, and the K is specifically focused on Kubernetes, not necessarily any
Correct.
orchestrator. Okay.
So this is the direction Microsoft is going. We've already announced that ACS is going to be deprecated in favor of AKS. AKS is currently in preview, so as soon as AKS GAs, there will be announcements around the timing, more specific timing of the deprecation of ACS.
You know, it's funny, when I hear you talk about that, it reminds me sometimes this is why we don't bring preview services into Azure Government, because we don't know if people say, why don't you have ACS? And it turns out now ACS is sort of going away because we're emphasizing this other thing, AKS. So we will have AKS in Azure Government?
Yes, we're working on making AKS available in Azure Government. We expect that to be available in the next several months.
Or depending on when someone watches this video, maybe we already have it available.
Correct,
okay.
Yeah.
All right, so what's this last thing, ACS Engine?
Yeah, so ACS Engine, I hope the name gives it away, is the engine that powers both ACS and AKS. It effectively gives you an unmanaged cluster, so there is no management for you, but it also supports multiple orchestrators the same way ACS does. It's not a service per se, it's actually the CLI or the application that both services use to do the provisioning of the clusters for you. So you end up with a configuration file where you say, I want a Kubernetes cluster, this version, this many nodes, I want this many nodes to be Windows, this many nodes to be Linux, I want my custom VNet. There's a bunch of flexibility that you provide that is available there then gets translated into an ARM template that gets published into Azure.
Okay, so you said it's not a service, so I might say, well, is this available in Azure Government, or can I use it in Azure Government? What does that mean as it pertains to ACS Engine?
It's mostly a matter of you can use it.
Okay.
It's available in the sense that you can use it for Azure Government.
So it enables me to stand up containers in Azure Government,
Correct.
Regardless of whether I'm watching this video and AKS is available or not.
Correct.
Okay.
So you can today, and I'll show you that in a second, how you can actually use ACS Engine to deploy your own Kubernetes cluster into Azure Government. The other thing I wanted to call out here is because this is the engine, this is the first thing that gets enhanced in order to provide new features. New features are available first in ACS Engine. You'll see things like custom VNet that's not available in AKS or ACS, available in ACS Engine because you have the ability to create your configuration file. Eventually, AKS will have this available once they slap on a UI that exposes this functionality that's available in the engine.
Okay, well, this is all sounding pretty good. I think it's time for us to look at a demo so you can prove this to us here.
Of course. So I want to show you first, real quick, how ACS and AKS work in Azure Commercial so you can see the relationship with ACS Engine. So starting right here, I'm in Commercial right now, and I'm trying to create an Azure Container Service. So you'll see right here that I'm getting prompted for a master configuration. As I said, in ACS, masters are exposed to you. So you can decide what are the DNS prefix, what URL I'm going to use to access the masters. I can provide my SSH key. Obviously, these two I haven't fully populated, but these are the coordinates that you'll use to integrate with Azure so that Kubernetes can actually create Azure resources on your behalf, things like storage and networks load balancers. And I can specify how many masters I want. And then I move on to the next section where I likewise configure which how many agents I want and what VM size I want.
So this is ACS, not AKS.
Correct.
Gotcha.
Yeah, as you see, we have the master configuration being prompted for, and also right here, you'll see that it prompts me which orchestrator I want.
Gotcha.
Note that it doesn't ask me which version, so this is a simplification that ACS does for you. Now, in the AKS world, so now I've switched over here, you can see up here that it's AKS preview. And it actually doesn't prompt me for which orchestrator, since this one is tailored towards Kubernetes, but it does prompt me which version I want. Then you'll see that I actually only have the ability to configure agents, as the master are abstracted for me, but it looks pretty similar outside of that.
Although even more simplified.
Yes.
Awesome.
And then the key thing to remember here is look at all these configuration parameters. So you have a username, which is what will be used to remote into the master or the agent in this case, the SSH key, the service principal configurations to talk to Azure, node count, and the VM size. So now let's flip over to ACS Engine. ACS Engine is available in GitHub. You can download it. You can download the source. You can contribute it. You can add your own features, of course.
So true open source.
Open source.
Okay.
And once you download it, you have all the guides here around how you can go and configure any one of the orchestrators and leverage more advanced features like custom VNet, as I said. So I've already created a configuration file, and you'll see that this looks oddly familiar. Does this ring any bells?
Yeah, it looks like an ARM template.
Yeah, it's actually the JSON file that's used to drive ACS Engine, and it has the same, pretty much the same, plus a few extra parameters that are available in the UI for ACS and AKS. So you see the DNS prefix, username, SSH, service principal, client ID, and client secret. You'll see the same things here: client ID, client secret, the SSH key, user, VM size, all those things. So it's really the same thing.
Really, we can practically map it to that UI that we saw.
Yes. So now I've created a file where I actually populated my SSH key and client ID and client secret. Of course, I don't want to show everyone my secret and my SSH key. But I'm going to go ahead and deploy this real quick, so you can see how simple it is to deploy a Kubernetes cluster in Azure Government.
I notice you're using Visual Studio Code here, so you can use this on any operating system, Windows, Mac, Linux.
Correct. This machine is actually a Linux machine. So, and I could do this in a Windows box without any issues, but I just chose to show how we play nice with Linux as well. So all that I need to do is ACS Engine, and ACS Engine has several options here. You'll see they look very similar to the ones that I talked about. So it's really just deploy, which is go ahead and create the cluster, and I can scale, which is something that I can do in the UI in AKS and ACS. Now here you have actually other options, which is upgrade. I have a version of Kubernetes, I want the next version, you can go ahead and upgrade. And ACS Engine will be smart enough to actually cordon masters, orchestrate the whole thing, orchestrate the orchestrator, a little bit meta there. But it'll go ahead and do this for you, and you can do more advanced functionality here. So I'm gonna go ahead and deploy, so ACS Engine, deploy, and I'm going to do it to US Government, Virginia. Subscription ID. So where do I want this? I'm just going to go ahead and get my subscription ID. So I'm going to go deploy it in my shared one.
So copying the subscription ID so we can paste it over here.
Yes.
And that was the Azure command line tool that you used to get your subscription.
Correct. And let's see, what else do I need? Azure environment, of course, and that's the key for Azure Government, as most of our government developers should be used to at this point. For every API, for every SDK or tool, you need to specify that you are not working against commercial, but rather using Azure Government. So Azure US.
In addition to the location I saw over there, US Gov Virginia for that region. Okay, as well as the environment. Okay, cool.
And let's see if my memory serves me right. No, I need to specify, of course, the API model, and that's going to be the file that contains a configuration. So API model.sacagov. So that's the cluster I'm going to create.
So fundamentally, ACS Engine is a command line tool, and even if you don't know all the parameters, it gives you pretty good guidance as, oh, you missed this one parameter right here.
Yeah, correctly. And actually, in this case, I've provided all my configuration in the API model file, but as you can see here from the results that came back, I could override those when I call the generate command, the deploy command. So I'm going to go ahead and kick that off, and now you're going to see in a second that it's deducing what the resource group name is, because I did not specify it. It makes some assumptions here. And it's going to start provisioning to Azure Government. So in a second, we're going to switch over here and look at my Azure Government subscription. Here we go. Resource groups. So Saca GovCube is a cluster that I already created, so I can continue showing off my demo since it takes a little bit, about 20 minutes for a cluster to be created. But Saca GovK, if we see here, Saca GovK is the one that's getting deployed by ACS Engine. And over here you can see the deployment. So we're going to see it's already starting to create some resources. Generally, the creation of resources is really fast. What takes a little bit longer is all the custom scripts that get run that configure Kubernetes for you.
So these resources we're seeing were just provisioned by the command line you just ran.
Correct.
Awesome.
You can see here the deployment that actually deploying, so it just ran. And over here you can see all the deployments, all the resources that it's creating. You can keep refreshing this to see
almost like a real-time update as to what's happening during our provisioning process.
Correct. So you can see here that it's already created the network, and it's now proceeding to create the VM. And then if I keep refreshing this, the VM will have completed, and you'll see the custom script extension.
Okay. How long does this usually take, just for a normal person doing this like us?
It can take anywhere between 10 and 20 minutes, depending on the size of yeah, correct.
Okay.
So I'm going to go ahead and just show you how you can actually use this cluster now that's already been set up. So now I'm switching over to Kubernetes world, where I actually have YAML files that leverage, that define what my application is going to look like. Actually, before I even go there, I have this. This is the container that I'm using. I have a simple application file that basically does some faux pas with regards to development. It actually takes in a parameter in the request and uses that to access the file system, which is a big no-no.
Yeah.
The intent here was to demonstrate, and I can easily do it, that even if you can hack it to obtain files from my machine with a container, it won't be able to access anything valuable because it'll be containerized.
Okay, so this is our caveat here. This is just for demo purposes. We're not recommending this.
Yes, of course.
We've made all the necessary warnings here.
But this application basically gives you abstracts for books. They're pretty short and sweet abstracts. I've already packaged this using a Docker container file, so you'll see here that I'm basing off the Python image. And I go ahead and set up a working directory of my application, install all the requirements, which is basically Redis cache and Flask. It's the framework that I use for the HTTP or the IIS equivalent of this, and basically expose a port, run my application.
Okay, so it's a Python web API, basically.
Pretty much.
Okay.
So now I published this into Docker Hub so that my cluster can actually retrieve this. And now in my deployment, I have already configured that I want a deployment over here. So let me actually run this real quick. Sorry.
So here you're about to do the deployment.
Yes, I'm actually going to deploy my application into the other cluster that I already have. So kubectl is a command line tool that lets you talk to Kubernetes.
All right, so at this point, we don't need AC Engine anymore. AC Engine is just for the provisioning. Now you're just in the Kubernetes world.
Yeah, now I'm Kubernetes world.
Great.
And I actually can talk to my Azure Government hosted cluster and just say get nodes. You're going to see here that it's going to show all the nodes that are available in Azure Government in my other cluster. So you can see here agent pool 2392. Let me switch over here real quick to my other cluster. And you'll see these 2392 VMs. So it's talking to this guy. I'm going to go ahead and kubectl, create, and I'm going to give it the file, which is the books application.
That Python web API, right?
Yes.
Okay.
Deployment books.
And these commands you're running, these kubectl commands, are just what any Kubernetes developer would use. You're just nothing specific to Microsoft. This is just straight Kubernetes.
Correct. This is standard Kubernetes. And now it's gone ahead and created the books deployment and the service. That's effectively what's exposing it to the outside world. So kubectl get pods. These are the actual instances of containers running. So if you look at my configuration file back here, I said I want 5 of these. You'll see those 5 over here. They're already up and running. Now kubectl get service. And you'll see now that it's actually pending getting an external IP. So what this is doing, and this is part of the big value out of Kubernetes, is that it actually talks to the underlying cloud provider. In this case, it's talking to Azure Government and saying, give me a public IP address that I can then associate with this service in this application.
Okay.
So it's going to take a few minutes, actually a few seconds, hopefully, and then we'll be able to access this application.
Okay. So we'll be able to access our Kubernetes Python Web API running in the cloud in Azure Government, managed by Kubernetes.
Correct. So now the other thing I wanted to show while this loads is that I actually don't have to do this by hand. I can actually use Visual Studio for a continuous integration, continuous deployment pipeline.
Okay.
So right over here, I've set up my code over here. In Visual Studio, it's the same application, it has the same configuration files, and now I have a build associated with this. So let's look at that build.
This is VSTS, Visual Studio you've used to write the code, and then you've checked the code into VSTS, and this is our cloud system.
Correct. And I've configured VSTS to talk to Azure Government, both to Docker Hub to be able to publish the image, which is where I'm hosting it, the container, sorry, and to my Kubernetes cluster that's hosted in Azure Government.
So we can set up a nice CICD pipeline.
Yes, correct. And you can see here where I've configured both my Docker Hub configuration to publish the container, and over here my configuration for Kubernetes.
Awesome.
So VSTS actually has first-class tasks that let you do this integration pretty easily. It's a matter of a drag and drop where I can actually just go in and pick I want a Docker activity, and what I want to do in this Docker activity is build my container, and then I want to push it to my account. That'll make it available for others to use. So if you go to my Docker Hub account.
So when you say push it to my account, this is like my container registry.
Correct.
All right.
But I'm using the public one.
So you are opting to use Docker Hub as your container registry, but you have your choice which one you want to use.
Correct. So I'm going to search over here. And I have this books. This is my books container.
Okay.
And then you will see here, these are actually build numbers. So these are the builds. I published 36. That is my last build that I did a bit earlier, and it published a new container.
Okay, great.
So this is the Docker Hub piece, and then there's the Kubernetes piece where, again, using a first-class activity in Visual Studio, I can actually say, go apply or update my deployment and set to the latest image. So let's switch back real quick. So now I have an external IP address, and we'll see this real quick over here. You'll see now that there is an IP address provided over here.
Okay.
This is the IP address corresponding to the one that Kubernetes asked Azure Government to provide. And now if I go to my application.
So now I'm hitting Azure Government in the cloud, and there's your app.
There's my application.
Okay.
For now, you can see this wonderful, beautiful application that has some abstracts for books. For example, Moby Dick. What is Moby Dick about? It's about man versus whale, and the whale wins.
Okay. Now you had mentioned something about security.
Yes. So over here, you can see one of the things you can do is to hack this application is remember I said that this parameter is being used to read a file. So if we go back to my application, in my container, I have books, and this is where the abstracts are held. So this is in a file that's actually taken from this parameter. So if I actually do something like this, I can traverse back the path. It's actually accessing the user file in Linux. Now, the application has bad code. There's nothing changing that. But if I was to run this on my application, this would contain my list of users. Whereas if I was to run this even on my machine but with a container, it would still show the standard user file.
So that's just another example of the additional isolation we get with containers.
Correct. The last thing I want to show is just exercise the CICD pipeline. So let's go over here. Let's make a little tweak to our application. Let's change the file. So get a super short, accurate, and awesome, and super awesome book abstracts. Git status. Let's see that it's already made the change. So git commit, and I'm going to say update description. Git push. And now it's going to go ahead and make the change. You can see here it's talking to Visual Studio. So let's switch over to Visual Studio, and let's check.
Specifically VSTS, not the Visual Studio we
Correct.
wrote code with, but our cloud-hosted CI/CD.
Yes, so you'll see over here that it's a build in progress that was automatically triggered. I've set it up as a trigger when any pull request comes in or there's a commit that it actually triggers. We'll see over here in the code the commit that came in. You see my update description, and we can switch back to the build and see it progress.
So just by checking into source control, it automatically kicked off the CI/CD pipeline, which can build the code and even potentially deploy your.
Yeah.
Great.
So we'll see over here. It actually provides a very nice visualization. I'm stuck in the queue, but let's switch back to my previous build so you can see what it looks like. Let's go over here. So over here, this is a previous build, build 35, and you'll produce an output like this. That's effectively running through all the tasks, so you can see the same things that I showed previously: publish the book's image, build the image, or rather the container, push the container, go make the apply it in the cluster, and update the container in the cluster.
Awesome. All right, great. How do I get started? Where should I go if if someone that want to get started on Azure Government? What's the best place for me to go at this point?
We have a few resources for anyone interested in Azure Government. So our short links here, AKMS Azure GovDev is where we have all of our quick starts. We'll be having a Kubernetes one pretty soon that explains how to do this yourself. We also have samples out there that show how to do more advanced scenarios, not just set up a Kubernetes cluster, but even how do you set up an application, like in my case. You can actually request for help for using the Azure Gov tag in Stack Overflow. And lastly, any feedback that you have, whether it's I want a new service, I want this feature, go to the Azure Gov feedback forum where you can post your requests, and we are closely monitoring that and providing answers.
All right, awesome. Well, this has been packed with information. Thanks for joining us. This has been Steve Michelotti with Saca from the Azure Government Engineering team talking about Kubernetes on Azure Government. Thanks for watching.
Thank you.